Okay, we're going to start back over on number 9 from lesson 20. And the first thing we did is we found the factors of the constant 1, 2, 4, 8. And we're going to try to find all of the possible real rational roots. And so we said we're going to go plus or minus those factors, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, over. The leading coefficient was 1. All of the possible factors of the leading coefficient. And so we ended up with, as possible factors, negative 8, negative 4, negative 2, negative 1, positive 1, positive 2, positive 4, positive 8. And then we began to do synthetic division with those, and we got some misses. But what were our misses? Which ones did not work that we tried? The positive 1 did not work. Negative 2 did not work. Negative 8 did not work. Did we find one that did work? Negative 1 was the first one that did work. And so here's how that would have happened. We would have taken our coefficients, 1, negative 2, 1, 12, 8, 1, negative 2, 1, 12, 8, and we'll do synthetic division. And we're trying the root of negative 1. And what are we trying to get? A remainder of 0. So to do synthetic division, we bring down 1. And then we multiply. Negative 1 times 1 is negative 1. And then we add negative 3. Then we multiply. Negative 1 times negative 3 is positive 3. And then we add 4. And then we multiply negative 4. And then we add 8. And then we multiply negative 8. And then we add and we get a 0. And because we got a 0, we knew that minus 1 was a root. Is everybody caught up? Because this was already written on your paper. Okay? So this was x to the 4th. So we know that this is an x to the 3rd. So it's a 1x to the 3rd. And then we descend minus 3x squared plus 4x plus 8. If the root is a minus 1, the factor looks like a plus 1, right? So that's where we're at. We've gone from a quartic to a cubic. Now we need to go from a cubic down to a quadratic. So we need to begin the synthetic division process again. Now, we're still not going to try the ones that didn't work. If they didn't work to start with, they're not going to work again. But just because we used a minus 1 doesn't mean we don't try it again, because that root may appear twice, right? If it appeared an even number of times, remember it would bounce at that root. If it appeared an odd number of times, it would cross at that root. So we're used to the fact that roots may appear an odd or even number of times, okay? Now, we tried it again. Did the negative 1 work a second time? When we tried it, we didn't get that far. It works a second time. Okay, somebody's already moved ahead. So we'll try that. So now we're going to take these coefficients. There's a 1 and a negative 3 and a 4 and an 8. 1, negative 3, 4, 8. And we're going to do synthetic division, and we're going to try that root of negative 1 again, because a root can appear more than once. And so we bring down 1, and then we multiply. Sorry, Mom. I'm having trouble here. We bring down 1, and then we multiply. Negative 1 times 1 is negative 1. And then we add and get negative 4. And then we multiply and get positive 4. And then we add and get 8. and then we multiply and get negative 8, and then we add and get 0. And since we got a 0, we know that it's a root again. Okay, everybody got that? I went kind of fast on the synthetic division, making the assumption that we all understand that at this point. Notice here we're at x to the third, so this one is going to be an x squared minus 4x plus 8. And now we've got an x plus 1, another x plus 1, and then all of that equals 0. So we've gone from a quartic to a cubic to a quadratic. Once we get to a quadratic, then we can solve by factoring or the quadratic formula. Now, did we get rational root? Did we get radicals in the answer? The final answer, did it have weird answers? So the x squared minus 4x plus 8 doesn't factor very nicely. So if you tried to factor, you'd be using up some time. So we're going to use the quadratic formula because we've asked somebody and we already know that factoring is not pretty, so we're just going to skip that and go here. Okay, so we're going to use the quadratic formula. Now remember that the a of this quadratic is 1, and the b of the quadratic is negative 4, and the c is 8, and we're going to plug that into the quadratic formula. So we're going to have x is equal to, remember the quadratic formula is the opposite of b. B was a negative 4, so we put a plus 4. Plus or minus the square root of. My b value, which is negative 4. Remember when you square a negative, we have to put quantity square. Negative 4 squared minus 4 times the a value of 1 times the c value of 8 all over 2 times the a value of 1. So since x squared minus 4x plus 8 does not factor nicely, we're going to plug it into the quadratic formula to get our final two roots. Okay? We're going to do the exponent, the multiplication, and that multiplication. So we're going to have x is equal to 4 plus or minus the square root of negative 4 squared is 16. 4 times 1 is 4 times 8 is 32. You're multiplying with an odd number of negatives, so the answer is a negative all over 2. We will continue to simplify the radicand, and so we're going to have x is equal to 4 plus or minus the square root of negative 16 over 2. The radicand is simplified, and so now we're going to take the square root. What times itself is negative 16? What times itself is 16? 4. What times itself is negative 1? I. Remember that I square is negative 1. Therefore, the square root of negative 1 is I. The square root of 16 is 4. Square root of negative 1 is I. So we get plus or minus 4I. Square root of negative 16 is 4I. Over, 2. Now, you can actually reduce because 2 goes into this and that, right? We're actually distributing division. So we can reduce that to x is equal to 2 plus or minus 2i. You can only do that if it goes evenly in both of them, right? So those solutions would look like then, my zeros are negative 1, another negative 1, 2 plus 2i, and 2 minus 2i. So those are the 4 zeros of the quartic. Any questions on number 9? Okay. All right, that was the last one, I believe. Any questions on any of that? All right, appreciate your attention.